Okay, so last section we're going to look at is 8.4. And it's on still using complex numbers in trig form. So if we're given something in standard form, we have to find two things, radius and angle, just like we did yesterday. But what we're going to do for arithmetic is a little different. We're not going to multiply and divide. We're going to raise numbers to powers, and we're going to take roots. Let me show you why the theorem we're about to learn is pretty handy. So let's say you wanted to do this. Okay, I want to raise that complex number to the second power. That's not that bad. All right, I can write it out. 3 plus 2i means to do it twice. And now I have to FOIL everything out. So I get 9. 3 times 2 is 6i. 3 times 2 is another 6i. And 2i times 2i is 4i squared. But then I got to combine all the like terms. So 9 plus 12i. I have to remember that I squared is -1. So that's really 4 times -1, which is -4. Then I got to combine like terms again. 9 minus 4 is 5. So if you know what you're doing, it's not that bad to square something. You can do it in 30 seconds or less. But let's say they gave me 3 plus 2i to the 8th power. Well, now I'd have to write 3 plus 2i 8 times in parentheses and FOIL each set of parentheses one at a time. That's going to be probably 40, 50 multiplications, additions, and combining like terms. It's going to be a lot of steps. I could probably still do this problem in under 10 minutes, but it's going to take a little while to get that done. Now, if you said 3 plus 2i to the 834th power, that's impossible pretty much to do by hand. There's going to be thousands and thousands of steps. And if you make one mistake in one step, it's going to mess up the whole thing. Plus, even just writing 3 plus 2i in parentheses 834 times, that's going to take like an hour just to write all that out. So if we do this in trig form, it doesn't matter if you give me this problem, that problem, that problem, or that problem. I can do all of them in the same amount of time. Right? So that's the advantage of trig form. Right? Makes raising to powers very, very simple, where doing that by hand is nearly impossible. All right, so let's look at a number in trig form, just a generic number. I don't have a specific r, and I don't have a specific theta. Just in an actual problem, you will have values, but not for this. Now, I'm going to write two identities on the board that we did back in section 7.5, because they're going to pop up here, and you need to remember what they are. Cosine squared minus sine squared equals cosine 2 theta. Right? Put the thetas in. Okay, that was called a double angle identity. Cosine squared theta minus sine squared theta equals cosine 2 theta. The other one that came up was 2 sine cosine, and that was sine 2 theta. 2 sine theta cosine theta simplifies to sine 2 theta. Okay, that's from section 7.5. And those are called double angle identities. We had double angle identities, we had Pythagorean identities, we had a whole bunch. But just these two we need to know right now. Okay, so let's take this number and let's raise it to the second power. So what that means is I'm going to write it out twice. R cosine theta, I sine theta. R cosine theta, I sine theta. Now, what you have there are 4 different factors. Okay, I'll underline the factors. 1, 2, 3, 4. Those are the 4 big things you're multiplying together. Now, if you're multiplying 4 things together, like A times B times C times D, Could I do B times D times C times A? Is that the same thing, or would that change the answer? It's the same thing. So when I want to multiply these four things together, I'm going to multiply the two together that look similar. R times R. I'm going to start with that. What would that be? R squared. So it's like we just multiplied these two together. And I'm just going to put the answer in front. R squared. Now, I have the second and the fourth, and those have to be FOILed together. Okay? Again, the R's are already taken care of, so you can kind of ignore those. They're done. Cosine times cosine. What's cosine times cosine? Cosine squared. Now we have cosine times I sine. Cosine times I sine. How many of those do I have? 2. Cosine times I sine. Another cosine times I sine. So I have 2 of the cosine I sine. It doesn't matter where you put the I. I mean, you can put 2 cosine I sine. You could put 2I cosine sine. They're all multiplied together. I just like to put the I in front of everything. Okay, so I have cosine I sine, cosine I sine, 2 cosine I sine. And now the last part. I sine times I sine. Well, what's a positive times a positive? Positive. I times I is how much? -1. And cosine, sine times sine. Sine squared. Okay, so what I'm going to do is I'm just going to reorder that a little bit. I'm not going to do a lot. I'm just going to put some things next to each other. So hopefully you start to see maybe some identities here. The R squared, I'm just going to leave that in front. Cosine squared, I'm going to leave that right where it is. Sine squared times -1. What is that really? That's negative sine squared. Cosine squared minus sine squared. Okay, cosine squared minus sine squared. Now the next part, I'm going to put, how do I want to do this? Let's do I times 2 times cosine times sine. Didn't really do anything big there. I just switched the I and the 2. It's like saying 2 times x, x times 2. Same thing. Now, look at this part right here. Cosine squared minus sine squared. What did I say earlier that simplifies to? Cosine. Cosine 2 theta, yes. So that's going to be R squared cosine 2 theta plus, now look at that part, 2 times cosine times sine.
Sine 2 theta.
Yeah, 2 times cosine times sine. That part turns into sine 2 theta. And the I just stays right where it is. That doesn't do anything. So, when we squared what I circled in red, we got what I put the box around in black. So what I really want to look for is the pattern. What happened from the red circle to the black box when we squared, right? And if you can see that pattern, we can probably figure out z cubed without doing all that work again. Does anybody have a guess what would be in the front when I do z cubed? Yep. It would be r cubed. Yep. So it would be r cubed. And now there's one more thing to figure out. What do you think the angle would be?
It would just be 3 theta.
3 theta, yes. So the pattern here is if you want to raise something to a power, you have to do two things. You raise the radius to the power, and you multiply the angle by the power. So if you wanted to do this to the 10th power, you would have r to the 10th cosine 10 theta, I sine 10 theta. A lot easier than having to FOIL out 10 sets of parentheses, right? Just those two steps. And this is called DeMoivre's theorem. So if you want to raise any number in trig form, and that's the whole key, you have to have it in trig form. And that's what we learned yesterday. It can't be in standard form. If you want to raise anything in trig form to a power, step 1, raise the radius to the power. Step 2, multiply the angle by the power. And doing that takes the place of all the foiling, all the I-squareds, all that stuff you would have to do, especially if you had to raise something to like the 50th power. This would take the place of writing 50 sets of parentheses and having to FOIL 50 times, which wouldn't really be doable. But remember, you've got to have trig form. That's the key. Okay.
Are you going to have us do anything like that on the test?
Like FOIL something 50 times?
Well, I mean more than like 5 times.
Well, if it is, you'd be using this theorem to do it. You wouldn't be doing it the old way. Yeah. Now, if you asked me to just square something like this, I can probably square that faster the old way because it's a small enough exponent. Because to do it with this formula, I'd have to change this to trig form and then use the formula. By the time I change it to trig form, I probably just could have done it out with FOIL. But if the exponent was like this, it's going to save me probably 40 minutes to change that to trig form and then use this shortcut. It's going to be much, much faster. So any exponents that are bigger than like 4 or 5, you really want to use DeMoivre's theorem. All right, so this is one you argue you probably could cube this out in a reasonable amount of time. It wouldn't really take that long to do it. But the next one we're going to do is to the 8th power. You would really need DeMoivre's theorem. So even though DeMoivre's theorem doesn't save you a ton of time on this one, let's practice it. And then we'll practice it one more time. Okay. Is that number that I just underlined, is that ready to use for DeMoivre's theorem? No, that's standard form. What are the two things that I have to find?
The radius and theta.
Radius and theta. So the radius, use the Pythagorean theorem. Square the first number, square the second number, and then add them up and take the square root. So Isabel, what's 1 squared? 1. Isaac, the square root of 3 squared? 3. And Nick, what do I get for a radius?
You get 2.
2. Yep. So there's my radius. So my radius is 2. Now I need my angle. Well, angle depends on the quadrant. Positive 1, positive root 3. What quadrant is it? 1. So the formula in quadrant 1 is what?
Inverse tangent x or y over x.
Inverse tangent y over x. Since x is 1, you don't really need to take that in. It's the inverse tangent of the square root of 3. Second, inverse tangent, square root 3. So we get a nice, well, it doesn't look like I get a nice answer, right? Because I'm in radians. But I always say do it in degrees first. And you'll see that that really is a nice answer. It's 60 degrees. If they wanted it in radians, I would convert that by hand and get pi divided by 3. That's where this number just came from. But just looking at the number 1.04, you'd probably never know that it came from pi over 3. Unless you did it in degrees first. Okay, so I'm going to just leave it in degrees. All right, so now write your complex number. R, parenthesis, what trig function comes first? Cosine of the angle plus, don't Don't forget your I, and then what trig function comes second? Sine of the angle. And now we're raising that whole thing to the third power. So now this is the part that's quicker. So how do I get my radius using DeMoivre's theorem?
Multiply by the exponent.
That's how you get the angle.
You raise it to the third power.
Raise it to the third power. 2 to the third power gives me 8. So my radius is 8. Cosine, sine. And now, how do we get the angle?
We multiply by the
Multiply the angle by the exponent. 60 times 3, which is how much?
180.
Yes, 180. 180. 180. And that's your answer.
We don't need to like distribute for everything.
So if they say to leave the answer in trig form, then you're done. If they say to put the answer in standard form, I'll show you how to do it. Very simple. All you do is distribute 8 to the cosine 180. You just type that in your calculator. 8 cosine 180. Write down what you get. -8. And now do the next part. 8 and distribute it to the sine 180. So 8 sine 180 is 0. So I have -8 plus I times 0. What's I times 0? It's really just 0. So in this case, in standard form, you just get -8. It's not wrong if you leave it as -8 plus I times 0, or some people might write 0 times I. But if it's 0 times anything, it really just cancels out. Okay. I'll do one later on where this part's not 0. But any questions on how to leave your answer in trig form or standard form? Okay, so let's look at this one. This is not one you'd really want to attempt by hand. Okay, 8 sets of parentheses, and you got to FOIL all that out. Probably going to make a mistake. Okay, I think we actually did one, maybe this exact problem in the homework. Let's find the radius. Now, since you're going to square the real part and the imaginary part, do negatives make a difference when you square something? No. They make a difference in terms of what quadrant you're in, but that's the angle. That's the next part. So when you square square root of 2 over 2, does anyone remember what you get? A half. You get 2 over 4, which is a half. And then you're doing it again. Square root 2 over 2 squared. It's another half. So what's the square root of 1/2 plus 1/2? 1. So this time your radius is 1. And your angle, well, let's figure out the quadrant. Negative, positive.
2.
That's quadrant 2. Do I have to add 180 if I'm in quadrant 2?
Yes.
Yes, I do. So 180 plus inverse tangent. Now, you can type all that in, but look at y and look at x. If you divide y and x, what would you get?
Oh, are we talking about the first one or the second?
Well, this is y and this is x. -1. Y and x are opposites. So if you divide two numbers that are opposites, you just get -1. I mean, if you want to type all that in the calculator, you can. But that's a lot of parentheses and square root stuff. It's a lot easier if I just type in inverse tangent -1. And if you do that out, that's what you'll get on the calculator, 135. Any question on how to type in 180 plus inverse tangent, -1? Now let's write out what we've got. R cosine 135 plus I sine 135. And we're raising that all to the 8th power. What's my radius going to be? 8. No, 1.
1 to any power is 1.
Right. 1 times 1, 8 times, is still 1. So 1 to the 8th power is 1. What's the calculation for my angle going to be?
35 times 8.
135 times 8. Now, that's 1080. That's kind of a big angle. Probably going to want you to make that angle smaller. So what can you subtract from that to make it smaller?
360.
You can subtract 360. Once, twice, actually do it 3 times. So that 1080 is the same as 0. Okay, so I'll just put started as 1080. But 1080 is big, so we always want to make it smaller by subtracting 360. Okay? Sam?
Wait, would the cosine of 360 be the same as the cosine of 0?
Yes, which is the same as the cosine of 1080. Yep. What form is that I just left it in? That's trig form. Okay, let's do it in standard, just in case they ask that on the test. To do it in standard form, what do I have to do? Distribute what in this case? The 1. 1 cosine 0. Again, the 1's not going to change anything, but you get 1 plus I times, and now distribute 1 times sine of 0. 1 sine 0. 0. What's I times 0? 0. So really, the answer here is just 1. That's standard form. So if you're wondering, well, where'd the I go? It was 0. So if you want to leave it as 1 plus 0i, you can. You wouldn't get that wrong. But it's really just 1. Any question on that? Okay, so let's go back, and now we're going to kind of transition to the next thing we did. So if we go back and look at example 1, we took a number and we cubed it. We raised something to the 3rd power. How would you reverse that? If you wanted to undo cubing something, you would take the answer that you got and do what? Yeah?
You would square it, so you have the little 3 on the outside of the square.
So what do you call that? Cube root. That's a cube root. So if you want to undo cubing, you do a cube root. Alright? So let's look at something a little simpler, and then I'm going to go back to example 1 and ask you the same thing. Let's say I start with the number 2. That's what I'm starting with. I want to cube it. So on the other side of that arrow, I'm going to put the answer that you get when you cube it. What's 2 cubed? 8. Alright? Now, I want to go back. What did we just say undoes cubing? Not square root.
Cube root.
Cube root. So if you take 2 and you cube it, you get 8. If you take 8 and cube root it, you get 2. You go back to what you started with. Right? So now let's look at our answer. We took 1 plus root 3i. That's what we started with. And we cubed it. And when we cubed it, we got -8. That's the answer that we got when we did it. So what would undo cubing that? The cube root. So if you take the cube root of -8, what would you get? Look at what the board says. You should get the original answer, which is 1 plus root 3i. So if you, what we just did here, by taking the cube root of -8, one of the answers is this. Okay? There are other answers, like if you said, well, what about -2? Yes, -2 times -2 times -2 is also -8. So when you take roots, there's more than one answer. That's one of the answers for the cube root of -8. How do I know that? Because we took that answer, we cubed it, and we got -8. That means if I cube root it, I go back to what I started with. Right? So that's one of the answers for the cube root of -8. In general, when you're looking for an answer, there's always going to be as many answers as the root. If you're doing a square root, 2. Cube root, 3. 20th root, 20. You'd have 20 different answers you'd have to look for. We'll probably do one up to like 5. Okay, looking for 5 answers. So that's what I just said. If you take the cube root of -8, which is reversing what you did in example 1, you'd get back what you started with, which means that number must be the cube root of -8, or it's at least one of the answers. If you want to know the other answers, -2 is the other answer, and 1 minus root 3i is the other answer. So once you find some of the answers, there's a pattern to the other ones. Finding the first answer is usually the hardest. The rest of them aren't as hard after that. Right, so I'm going to show you how to find roots. Okay? What I'm going to do is, as we go through the steps, we're going to do the step on an actual problem. So you're not going to understand how to find an nth root the first time through. It's probably not going to make sense. If it made sense, you wouldn't be taking pre-calculus. You would already know this. So it's the kind of thing you just have to go through a couple of times. I would say the steps, I don't know how big you write or if you have a small space, but you're probably going to need like 8 or 9 lines to write the steps. Maybe only 3 or 4 lines if you write real small. I don't know. Maybe a whole page. Probably not a whole page. But so I'm going to write the steps, and then I'm going to do that step in an example. All right. So the first thing is you have to set up an equation like this. Okay? This n is what you're taking. It's your root. Right? Are you finding a square root, cube root, 4th root, 5th root? We're going to do a 4th root in this problem. That's why I put the number 4 as the exponent. The number that you put here, that's what you're taking the root of. Okay? Taking the root of. So in this case, we're taking the roots of unity. If you've never heard that word before, unity is just a fancy way of saying the number 1. Your book uses that number, or uses that word sometimes, so I just want you to see it. I usually would just say 1, but we're just going to find the roots. We're not actually going to graph them, so you don't have to worry about the graphing part. So this problem is to find the 4th roots of 1. There are 4 answers. Okay. Can anybody think of a number times itself 4 times that gives you 1? 1. Yep, and -1. So those are going to be 2 answers that come up here as we go through the process. It doesn't really help you to write those answers down right now because we have to find all of them and we just want to use the process. Because you might not be able to guess an answer like that on the test. Okay. But that one is a little easier. Okay, so 2 of the answers are 1 and -1. So just remember those. And we'll come back to them. All right. So that's the first thing you do, set up this equation. The Exponent is your root. The number on the other side is what you're taking the root of. Now, this just says that a and z are complex numbers. We are dealing with I. They don't have to be real. Okay? You can get complex answers. So if you just want to write it out the long way, just say z and a can be complex numbers. That's just the short way.
I don't write math in English.
Math people write that way.
Not me.
That's okay. So now we have to take that equation and rewrite it in trig form. That's not trig form. If it was trig form, I would be seeing sines and cosines. That's how I know something's in trig form. So now I'm going to show you how to rewrite that in trig form. Each side has to be written in trig form. The 4 is just going to stay at 4. The 4 is a 4. But the A and the Z have to be written in trig form. Now, for this one, you actually have to find the R and the theta for the number on the right-hand side. That's A. Okay, you have to find those. How do you find them? That's what we learned yesterday. Use the Pythagorean theorem to get R. Use inverse tangent to get theta. So you have to find those. For Z, you put in exactly what you see right here. So just copy this. This part, just copy it exactly the way you see it. Wherever you see Z, you're going to change it to that. R cosine theta plus I sine theta. So I'm going to plug that in right now. Change Z to R cosine theta plus I sine theta. So this is going to go away. I won't cross it out because then you won't remember what it was. But that's going to disappear. R cosine theta plus I sine theta. Leave the 4. The 4 didn't go anywhere. That's still there. So now the left-hand side is in trig form. It has sines and cosines. So up to this point, we haven't done any calculations. All we've done is change something on the left with what I told you to change it to. Now on the right, we need to find some things. We need to do some calculations. Right? So what I'm going to do is right here, look at the number 1. What's the imaginary part there? 0. So if you want to put that, you could. I usually don't, but it's 1 plus 0i. How would you graph that? It's going to be on the x-axis. Which way? I know, yeah, it goes this way, but do I go left or do I go right? I go right. How many units? 1. So I need to find out 2 things about that point. How far is it from the origin? You can use Pythagorean theorem if you need to. Usually when it's on an axis, you can just count. And I need to know the angle. So how far is that point from the origin?
1.
It's 1, yeah. If it wasn't easy to figure out, I would have just done Pythagorean theorem. Now, if the angle wasn't easy, I would do inverse tangent y over x. But it's on the axis. So this angle is easy to figure out. Yeah? How much? Yeah, how much is the angle? 90 would be if it was at the top. Okay? 0. So that's your angle. Cosine 0, I sine, just squeeze it in, 0. Now you've got your whole equation in trig form. All right, so now you have something that looks like this. In our problem, we have all these numbers filled in. R cosine theta, I sine theta, that looks exactly the same. But we don't put n in our problem, we do 4. Because our exponent is a 4. So I have 4. And then on the other side, we found these. You have to find those. R was 1, the angle was 0. So that's what we have right now. But we have more numbers in ours than this one because we filled in the numbers. Now, this part, right here, you want to use DeMoivre's theorem to do out the left-hand side. So, what would your radius be if you do out what I just circled? Not four. It's not going to be a number because we don't have a number. What do you do with your radius and your power?
R to the fourth.
R to the fourth. You raise your radius to the power. Now, how do you get your angle?
Multiply them by 4.
Multiply the angle by the power. So what's your angle going to be here?
Cosine 4 theta.
4 theta. Theta, I sine 4 theta. So that's the left-hand side done out. Normally you could just copy the right-hand side over. I'm just going to put equals so I don't have to write the whole thing again. If you want to copy it again, you can. Okay, so now you've got something like this. You have raised your radius to the power, r to the fourth, and you've multiplied your angle by the power. In our case, n was 4. 4 theta, 4 theta. The right-hand side has stayed exactly the same. So now we've set up everything we need to. We can now find the radius, and now we can get the angle. So you have a left and a right-hand side. Here's your left side. There's your right side. Does anyone want me to just copy it down again, or is it okay like that?
It's okay.
It's okay? All right. On the left-hand side, what's the radius?
R4.
R to the fourth. On the right-hand side, what's the radius? 1. What symbol is between the left-hand side and the right-hand side? Equal, right? Whatever's on the left has to equal what's on the right. Whatever's on the left has to equal what's on the right. That's the equation we're going to solve now for the radius. You could probably already figure out what number to the fourth power gives you 1, but I'll show you how to type it out. Now, what's the angle that's on the left? 4 theta. What's the angle? I want to do that in a different color. It doesn't really matter. What's the angle that's on the right? 0. What symbol is between the left and the right-hand side? Equals. So the angle on the left has to equal the angle on the right. Now, one extra thing we have to put here, and then we can finish the problem. When you're solving for a root, how many answers did I say the root has? 4. This is a fourth root. It has 4 answers. So if you didn't put plus what I'm about to tell you, you would only get 1 answer. To get all 4 answers, you have to put plus 360k. That's how you get all 4 answers. Why 360? Well, if you remember the period of sine and cosine, it's 360 degrees. If you did that in radians, you could put plus 2 pi. Okay, but I'm going to do it in degrees because then we get nicer numbers.
Are we going to do 2 pi k or just 2 pi?
You would put 2 pi k. Yep. I'm going to show you what k is in a second. I didn't tell you what k is. So at this step, now you've got r to a power equals r. In our case, r to the fourth equals 1. And on the other side, you've got n times theta, in our case 4 times theta. You've got the angle that you solved for, which was 0, plus Okay, and I'm just going to put in parentheses above it. 360 if you're doing degrees, 2 pi if you're doing radians. That's the hard part. We're like 90% of the way done the problem. Now the easy part, this part gets kind of repetitive. We have to write all 4 answers. Okay. So remember, roots always have a single value for r. Whatever the radius is, that's going to be the same. The way you get the 4 different answers is the angle is different. The radius is not, but the angle is. So before I tell you what k is and how you get the different answers, let's solve r to the 4th equals 1. How do you get rid of an exponent of 4? Take the 4th root. 4th root, 4th power, cancels. Now, you probably can figure out what the 4th root of 1 is. But if you don't know how to type it in, because maybe it's not always going to be a 1, this is how you, I'll just put this here for a second. This is how you type it in. To do a 4th root, you press 4, math, and then it's the 5th option down. That's how you do a 4th root. You press the root, go to math, and it's the 5th option down. And what are we taking the 4th root of here? 1. So what is the 4th root of 1? 1. That's just 1. So nothing interesting there. So I'm going to have 4 answers to this problem. Every problem is going to have r equals 1. So an nth root has n answers. 4th root, 4 answers. Now, what is that k thing for? Right here. To find all the answers, let k equal, you start at 0, and you go up as high as you need to get all your answers. So 4th root, I'm looking for 4 answers. I'm going to let k equal 0. 1, 2, 3. That's how I get my 4 answers. 0, 1, 2, 3. So I end up basically stopping 1 before. If I went to 4, 0, 1, 2, 3, 4, that's 5 answers. Okay? Because you're starting at 0, you don't need to go up to 4. Only go up to 3. So I'm going to write down each one of those. 1, 2, 3. So every problem has the same value for r. What did we find out r was? 1. So what I'm going to do, what I usually do, is even though it's a lot of repetitive writing, I set that all up first. Cosine, I sine, cosine, I sine, cosine, I sine. So now I have it all set up to write all my answers. I just have to figure out the angle for each one. Okay? That part's very easy. All we have to do is start by plugging 0 in for k. All right? Now, what are we solving for right now? What did we call our angle? Theta. So if I can, I would kind of like to have this 4 on the other side. So I have a formula like this. Theta equals, not 4 theta equals. How would you put that 4 on the other side? Yeah, you just divide it. Divide by 4. Divide by 4. What's 0 divided by 4? You don't even really need that part. If it wasn't 0, I would. What's 360 divided by 4? 90. So there's your formula for theta. Okay. And let's go through one at a time. K equals 0. What's 90 times 0? 0. 0. 0. K equals 1. What's 90 times 1? 90. 90. K equals 2. What's 90 times 2? 180. 180. 180. K equals 3. What's 90 times 3? 270. 270. I didn't really leave enough room, but that's okay. 270. So the first time that you go through it, you're kind of looking at the steps and doing the problem at the same time. It's not really going to make sense the first time we go through it. So we'll do, we'll start one more, try to go through it, and we'll see where we end up. If we don't finish it, I'll finish it tomorrow before the test. Okay. It's the kind of thing you got to practice it a couple times.
Is this going to be on the test?
There'll be one question where you have to find a root. Okay, I'm going to do example 5. Okay. Find the cube roots of -8. So how many answers are you looking for? This time just 3, so 1 less than last time. The fact that it's 1 less answer doesn't really save a ton of time. It saves a little bit of writing, but not that much. So the first thing you want to do is set up this equation. Z to the power equals what you're taking the root of. What's my power in this case? 3. Equals, what am I taking the root of? -8. All right, so there's our equation. Next thing is turn the left and the right-hand side into trig form. On the left, all you do is this. Just replace z with r cosine theta, I sine theta, and all of that is to what power? 3rd. Now on the right, you actually have to find the r and the theta. If you graph -8, what's the imaginary part?
0.
0. So how would you graph -8 starting at the origin? Left 8. What's your radius if you go left 8? Normally you'd use Pythagorean theorem. I don't think you need it there. Well, angle I'll come back to, but what's my radius? 8. So 8 cosine. Now what's my angle? I would normally use inverse tangent, but I don't think I need to.
180.
Your angle is 180. Okay. Now, on the left, do this out with DeMoivre's theorem. What's your radius going to be? R cubed. And what's your angle going to be?
Cosine 3 theta.
3 theta. Yep. Just equals that. Now, there's a radius on the left and there's a radius on the right. What's the radius on the left? What's the radius on the right? What's the cube root of 8? 2. There's your radius for the problem. So that's the same radius we're going to write 3 times. Now, what's the angle on the left?
3 theta.
3 theta. What's the angle on the right? 180. But to get all the answers, what did I have to say you have to put on the end of it?
Plus 360k.
Plus 360k. And now the last step before we write our answers, get rid of that 3. All I want is theta equals. So how do I get rid of that 3? Divide by 3, 3, 3. What's 180 divided by 3? 60. 360 divided by 3?
120.
120. And that's it. We're like 90% done. Now we just write all the answers. What are you going to let k equal to get 3 answers?
0, 1, 2.
0, 1, 2. K equals 0. K equals 1. K equals 2. What's going to be my radius each time?
2.
2. 2, 2, 2. Just copy this over a bunch of times. Cosine, I sine, cosine, I sine. Keep writing it out. That's why you're probably going to have one similar to this on the test, like a cube root, because at least it's only 3 answers. It's not like 8 or 9. Now, 120 times 0
0.
plus 60. 60. 60. Next one, k equals 1. 120 times 1. 120 plus 60? 180. 180. Last one, k equals 2. 120 times 2. 240 plus 60. 300. So it's not too bad once you learn the process. It just kind of takes a while to go through.
And then those are those are
That's it, you're done. Those are your final answers. You stop there. Yep. That's it.
I said free.
Okay, so homework tonight. It's on 458. It's 3 through 5, so like 3, 4, 5. 8 through 12, 26 to 28, and 35. So it's like 12, maybe 12 problems or so. We'll look at that tomorrow. Don't forget, I'm after school today if you need extra help.